Advanced Residential Applications and Case Studies, Chapter 8, Cost and Income Approaches, page 15, Market Extraction Method. Let's take this example line by line. Line 1 merely lists the sale prices of 3 comparable sales. They most likely are the same 3 sales you are using in the sales comparison approach, although you may choose to employ other sales. Line 2 subtracts the value of the land from the sales price of each comparable. Right there. Where did this land value come from? As a separate step in the cost approach, we had to investigate comparable land sales to ascertain the value of the subject land. Suppose we determined that the value of the subject land is $125,000. Then we look at sale 1 and determine that its land area is larger, so it should be worth $150,000. We look at sale 2 and decide that its land has less frontage and is a bit low in comparison with the subject's land. Sale 2's land would be worth only $100,000. The land in sale 3 is quite similar to the subject. We assign it a value of $125,000. So you can see on the first row was the sale prices. On the second is minusing the land value for each one, and you can see the examples we just went over, why they're valued at what they're valued. Line 3 is merely the difference between the sale price of each comparable property and its land value. For example, sale 1 sold for $495,000 and its land was worth $150,000. Therefore, by subtraction, the present depreciated cost of the building improvements would be $345,000. That's line 3. Line 4 consists. Line 4 lists the cost new of each of the comparable properties. Well, how the heck are we supposed to know that? If these are comparable properties, then their replacement costs should be quite similar to that of the subject. In the cost approach, we did have to calculate the replacement cost of the subject property. Let's assume that came to be $90 per square foot. Perhaps we decide that one of the comparables appears to be better quality construction than the subject property. So we might use $95 per square foot. One of the others might be lesser quality. For it, we might use something in the range of $85 per square foot. If these are comparable sales, we should know or be able to ascertain the square footage of each one to arrive at an estimate of cost new for each of these comparable sales. It's a simple matter of multiplication. Line 5 merely brings down the totals from line 3 to effect a simple subtraction. For example, in sale 2, we calculated the depreciated cost of the improvements to be $240,000 from its cost new of $413,000. Line 6 is the result of the subtraction of the numbers in line 5 from line 4 for each comparable sale. It appears that sale 3 has exhibited a total depreciation of $197,000. This has been extracted from the market. The last line then converts, in each case, the dollar amount of depreciation for each comparable sale into a percentage of depreciation. This percentage is based on its original cost new. For example, sale 1 lost $210,000 from its cost new of $555,000. Divide 210,000 by 555,000, which equals 37.84% of its original cost. In this case, the lump sum estimates of depreciation are in a narrow range. If one were to reconcile the indicated depreciation to 40%, then that amount could be applied against the cost new of the subject property to estimate the total depreciation in the cost approach. If the subject property had an estimated cost new of $530,000, then the total depreciation would be estimated as follows: $530,000 times 0.40%. Actually, that's not even a percent, really. It's just 0.40 equals $212,000. End of page. There's once again the grid we were working with. Page 16. More on market extraction method. However, as I'm sure you know, the data is not always so neat and tidy. We can make additional calculations which will make this data into a more useful tool in a variety of appraisal situations. Let's assume that the 3 sales in the previous example had effective ages of 25, 27, and 28 years. Let's do the math. Here's the grid. The second row says lump sum percentage of depreciation For sale 1, it's 37.84%. For sale 2, it's 41.89%. And for sale 3, it's 40.04%. Underneath that is the effective age, which for sale 1 was 25, sale 2 it's 27, and for sale 3 it's 28. On the last line of the grid is the average annual depreciation rate. For sale 1 it's 1.51%, for sale 2 it's 1.55%, and for sale 3 it's 1.43%. We could do a reconciliation and choose 1.5% per year as the indicated rate of depreciation. Then we can use that rate to predict depreciation amounts in homes of other ages. For example, a home that was 30 years old could be expected to have a total depreciation of 30 times 1.5%, or 45% depreciation. That is good by itself, but an interesting byproduct is that you can now take this average annual rate of depreciation and use it to calculate the total economic life of a home. It's the only way I know to mathematically calculate total economic life. If the subject home is going to depreciate on an average rate of 1.5% per year, how long would it take to fully depreciate 100%? 1.00 divided by 0.015 equals 66.67, which we can round to 67. Therefore, the total economic life of the home could be predicted to be 67 years. This means that at its current rate of depreciation, the home would have no contributing value to the land after 67 years. Likewise, if a home or other improvement were depreciating at an average annual rate of 2%, it would take 50 years to lose 100% of its value. End of page.